This is my simple inverter system setup. Consists of a 5 kilowatt inverter and a 14.3 kilowatt hour lithium battery pack. What do we power with this system? First off, there is no solar input because we have one or two issues with the roof which we plan on sorting out. So we mainly depend on the grid to get the battery charged. Luckily in this area we have a minimum of 12 hours grid supply, which makes grid dependence practical. It might not be the same in your area, other areas and all that, but because of that availability, the hours of availability makes grid dependence practical in my own case. So the critical loads in this case are the fans and the lightings. Then we have the freezer and the fridge. Because of the way the freezer works, it's going to take a long outage, maybe 24-48 hours before you start feeling the effect of the light not being available, because the freezer is always solid, so it takes a long time before it starts to defrost. So because of that, I made the decision of putting two sets of sockets by the freezer and the fridge. One is directly connected to the grid and the other is connected to the inverter. So by default is always connected to the socket that goes directly to the grid. So in case of maybe a prolonged power outage between 24-48 hours, then we start looking at putting it on the inverter. So the main loads on the inverter are the lightings and the fans. And you have other loads in the kitchen which are not connected to the inverter at all, although there is a socket there maybe in case of maybe emergency, maybe they need to use the blender and there's no light and all that, we can't wait, so we can actually do that. The inverter can support that. So everything is all about the bucket, the battery. It's not the inverter is 5 kilowatts, so it can support all those loads, but the bucket is the most important in this case. The stored energy, the battery in this case. So with effective use, the lightings and the fans, we can conveniently go 72 hours without having a recourse to the grid. So that makes it that's why the system is able to sit between the time of the grid outage and the grid coming back conveniently, because we depend on the grid solely for charging the battery. So streamlining the critical load to the most important is very, very, very important in this case. So because we decided to cut out the use of to make the using generator slim as possible, and for 7 months that has been possible. So this is a 14.3 kilowatt hour battery, which it's a fairly big bucket, which can run a long time if fairly managed. So the connection, the wiring is simple and straightforward, but a point to note: if you are not down with systems like this, you are not an electrician, you have no that good knowledge with wiring, electricity and all that, please, this is dangerous. Electricity can kill you. So it's good enough to get the services of someone who knows what they are doing. What I'm doing is just the purpose of general knowledge. It's good to get that out of the way. So the home consumer unit is on the other side of this wall. So the inverter is fed via a 30 amps circuit breaker. It comes in through this cable here. It passes through this. This is a voltage regulator. It serves as first line of defense for the inverter. It has over voltage, under voltage, and current protection. So this from here it comes through this circuit breaker here, which serves as a switch, as an isolator in case you want to isolate the grid from the inverter. So you go from here, it goes into the inverter, and the output of the inverter comes out through this circuit breaker here before it now goes back to the back. It goes through this hole and back to there's a knife switch at the other end. What the knife switch does is it switches between the grid power and the output of the inverter. In this case, it is sitting there so that in case there's something goes wrong with the inverter, if something goes wrong with the inverter, you can just quickly bypass the inverter and put the load back, the critical load back on the grid, so that there won't be, so that you have enough time to fix the problem with the inverter. So that's the AC side. And for the DC side, you have a 50 mm cable connecting the inverter down to our 14.3 kilowatt hour surplus battery pack. That's a lithium battery pack. You have a 250 amps breaker for the battery here. The battery is fully charged now, although it's not at 100%. Based on the setting, it stays at 98.7%, and there's a reason for that. This is the nice switch I was talking about earlier. This is the inverter output. This is the connection for the critical loads, and this is the grid input. So this switch provides effective isolation in case the inverter runs into problems. So by default, the switch sits here. So all the critical loads are connected directly to the inverter. It will only be taken up here in case we need to isolate the inverter in case of inverter issues. Talking about the solar input in your area, if you are not limited to the grid input alone, you don't have any issues with your roof, and you want to connect solar panels to this this 5 kilowatt Man solar branded inverter can take a maximum of 6,000 watts in terms of the solar panels. Then you have a maximum of 500 volt DC open circuit voltage input. So if I were to have 615 watt solar panels, if I divide that by 6,000, that means I can conveniently use 9 pieces. Based on, I think the VOC for each of those panels is not up to 50 volts. So we can still stay well below 500 volts. And talking about standard temperature and all that, in Nigeria here we don't, even the coldest in this area of Lagos will not make the VOC when the battery, when the solar panel will not make the voltage rise above 500 volts, which is not possible. This is a simple setup you can put up in your own place too, to keep your critical loads running. No complicated wiring, no mess. And if you have any technical questions, you can put it down in the comments. I will answer them as soon as possible. Thank you. Please like, subscribe, and share this video. Thank you very much.